Welcome to The Explainer. So today we're talking about AI that does more than just talk. We're actually going to draw up the blueprint for AI that acts. We're talking about the next wave, autonomous agents that can tackle real-world problems all by themselves.
I mean, for years now, we've seen LLMs do some amazing things, right? They can think, they can write, they can summarize, but the game is totally changing. They're not just thinkers anymore. They're becoming doers. They're learning how to connect all that brain power to actual tools and actions in the real world.
And that right there, that's the big question, isn't it? If you're an architect right now, this is what's on your mind. How do you actually build an AI that can act on its own? How do you go from a passive Q&A machine to something that can actively solve complex problems? Well, that's exactly the blueprint we're going to lay out today.
All right, let's get into it. Every agent, just like a car, needs an engine. This is its cognitive engine, the thing that drives all its decisions. And honestly, this is probably the most critical choice you'll make. It all starts with picking your powertrain, deciding how this agent is going to think.
So option number one for your powertrain is something called ReACT. Just think of it like this. It's a reason plus act engine. It's super pragmatic. The agent thinks about what it needs to do, takes one step, looks at what happened, and then uses that result to figure out its very next move. It's a lot like human trial and error.
And the real beauty of ReACT is just how simple and powerful this loop is. You can see it here. First, a thought, something like, I need to find some data. Then an action, like calling a tool or an API. And finally, an observation, where it analyzes the results. And then it just repeats, thought, action, observation. It's a really elegant cycle, and honestly, it's pretty close to how we solve problems ourselves, right?
Okay, but what happens when a problem is, well, messier? When one path just isn't going to cut it? For those really complex jobs, we've got our second engine option, Tree of Thoughts, or TOT for short. Instead of that one-step-at-a-time approach, TOT is like a chess master. It explores a bunch of different paths at the same time, evaluates which ones look good, and then doubles down on the most promising ones. It's a much more deliberate way of thinking.
And this right here really lays out the big architectural trade-off you have to make. Just look at this comparison. ReACT is linear. It follows one path. That makes it super fast and cheap on compute, perfect for simple reactive tasks. But then you have TOT with its branching exploration. It's way better for tricky situations with lots of unknowns like planning or complex problem solving. But yeah, it's going to cost you more in terms of compute. So the choice is pretty clear. You go with ReACT for speed, and TOT when you need serious strategic depth.
Okay, so you've picked your engine. What's next? Well, now you need a chassis to build the whole thing on. This is your agent framework. It's what holds everything together and connects all the parts. And really, there are two big players in this space right now, AutoGen and LangChain. Think of AutoGen as the ultimate collaborator. Its whole thing is getting multiple agents to talk to each other to solve a problem. It's amazing for really dynamic, creative tasks. LangChain, on the other hand, is more like an assembly line. It's all about modular, plug-and-play components for building really structured, production-grade workflows. It has a massive community and tons of integrations. Now, the source material actually gives some pretty solid advice for architects working on things like fraud detection. It says, start with LangChain. And the reason why is huge, MLOps. LangChain is built to fit right into your existing MLOps pipelines. That means your agents are easy to monitor, they're repeatable, they're reliable, all the stuff you absolutely need in a production environment. And hey, if you need that multi-agent collaboration down the road, you can always expand into it with LangGraph.
All right, so our agent is taking shape. We've got an engine, we've got a chassis. Now it's time for a really cool upgrade. We're going to install an onboard diagnostics system, a way for the agent to actually learn from its own mistakes.
This idea is called reflection, and it's pretty wild. Basically, when the agent messes up, instead of just failing, it stops. It gets prompted to literally reflect, in words, on what went wrong. It's like it's writing a post-mortem on its own failure, creating a lesson that it can remember for the next time.
And the process is super systematic. Check it out. The agent acts. Something evaluates if it worked. If it failed, the agent reflects on why it failed. It stores that reflection in its memory. And then it tries again, but this time it's smarter. This is huge because it's not just about getting it right once. It's about building an agent that gets better and more resilient all by itself, without a human needing to step in every time.
And you might be wondering, does this actually work? Well, yeah. The impact is not small. For really complex stuff, like analyzing fraud scenarios, adding a reflection loop can boost accuracy by, get this, 25 to 40%. That is a massive, massive lift compared to a standard agent.
Okay, so our blueprint is almost complete, but this last part is the big one. This is where theory hits reality. It's time to talk about the pre-launch checklist for taking your agent from a cool prototype to a rock-solid production system.
So before you even think about deploying, you've got to do your homework. We're talking about defining super strict SLAs, like what's your acceptable latency, what's your uptime guarantee. You need to figure out your cost baselines, and absolutely everything, your prompts, your tools, your agent graphs, needs to be versioned in Git, just like any other piece of production code.
And then it's time for the gauntlet. I mean, rigorous, hardcore testing. You need to run literally thousands of evaluations, hitting every weird edge case you can think of. You have to stress test it with tons of concurrent users. And you better have guardrails in place to stop things like prompt injection. You have to try and break it. And here's a fantastic pro tip right from the source material. Don't just hope your agent can handle failure. Prove it. You need to intentionally break things, mock an API failure, make a service go down, see if your retry logic and your backup plans actually work when things go sideways. This is so important.
And finally, it's time to lock it down and make it efficient. That means whitelisting exactly which tools the agent is allowed to touch. It means rate limiting APIs so it doesn't go crazy. Encrypting its memory is a must. And then you get into cost-saving stuff like quantizing your models or caching common results.
Which really brings us back to the central challenge for any architect building these things. It's this constant balancing act, right? On one hand, you have the incredible potential of what these agents can do, but on the other, you have the hard realities of production, reliability, security, and cost, and you can't ignore any of them.
So I want to leave you with one final question to think about. As these agents get smarter, as they start to reason and plan and even fix their own mistakes, what does that mean for the role of the architect? Are we still just builders, or are we becoming something more, like a trainer, or maybe, eventually, just a supervisor?